So now that we've computed the baseline predictor, we can go ahead and move on to the neighborhood predictor. And so the first step in computing the neighborhood predictor, as we said, was to find the error in the baseline for each of the entries. And we show that on the right-hand side over here in this table. And again, that error is the actual rating for the values that we have minus the baseline prediction. And we use this table to come up with the cosine similarity values. And remember, the cosine is always going to vary between +1 and -1. And we either want it to be very close to +1, indicating a strong positive correlation, or very close to -1, indicating a strong negative correlation. And so we can illustrate the computation of the cosine similarity using this table. Let's take, for instance, movies 1 and 3. The first step is to find the users that have rated both movies as part of the training data. So we have A, we have C, and we have D that have rated both. Remember, we can't use, for instance, E, because E has not rated movie 1 in the training set. So we can't use that. We also can't use F for a similar reason. So in order to compute the cosine similarity, we take the products along the users to compare their relative ratings. So in the cosine similarity here is going to be, we take -0.5, which is A1 times A3 of 0.1, and we take C1 of -0.4 times C3, and we add those, and then we add additionally -0.333 times -0.733. And so if we write that out, we have -0.5 times 0.1 plus -0.4 times -0.8 plus -0.333 times -0.733. And we're going to divide that by the sum of the squares of each movie's values that we're using. So A, C, and D for movie 1 and A, C, and D for movie 3. So we take the square root of -0.5 squared plus -0.4 squared plus -0.333 squared. We multiply that by the square root of 0.1 squared plus -0.8 squared plus -0.733 squared. And we do that computation out, we get on the top 0.5144, and on the bottom we get 0.7867, which is 0.6539. And so they're closer to +1, clearly, than they are to 0, these cosine similarities, but we wouldn't say that they're the most strongly positive correlation in the world. So 1 and 3 are positively correlated, but not necessarily a strong positive correlation. And similarly, we can compute these values for the remaining movie pairs, and we come up with this similarity table for each of the movies along the rows, by each of the movies along the columns. And then, as we did before, we go down each column and we select the highest one in magnitude, to be exact, which indicates the nearest neighbor. And so for 1, we're going to take 3 actually, which is 0.654. For 2, we're going to take 5. For 3, we're going to also take 1, so that's 3 takes 1 and 1 takes 3. And for 4, we're going to take 3. But notice how 3 did not take 4. 3 took 1 because there was a higher similarity there. And 5 is going to take 2, which has a relatively strong positive correlation relative to the other values in the set. And so now we can go on using these values to actually compute the neighborhood predictor.